So here's my Dapol Engage Class 22 locomotive. It's developed a bit of a problem where the output from the decoder keeps tripping. Lights are fine, sounds fine, but just no drive. So it's time to get it on the bench, do some diagnostics and see what's happening. Right, so here it is on the bench. So the first job is, let's get the body off. So I just use my nails to gently pry down the side. Some people use plastic removal tools, but I like to use my nails. Not too much force on the buffers, or else we'll easily snap a buffer off. So just gently prise in. Shouldn't get any resistance really, just keep prising the sides open until the cover pops off. You can see I've already marked the body for direction for reassembly. This locomotive has a sound decoder fitted to it as well, so hence the captain tape and the green speaker. The motor terminals on this model are very close to the body. I have previously put captain tape to make sure they are insulated, but they check out fine with a multimeter. So let's have a look at the motor and check the resistance there. And as suspected, the motor is low resistance. So 6 ohms just under, 6 volts over 6 ohms give you 1 amp in rush, which is way over the decoder rating. But that's a rough theoretical calculation, so we'll strip it down, get the motor out, and then we can do some proper testing with the motor on the bench. So let's remove the bogies, just give them a gentle pull and they should come away. And then once we got the bogies off, we can gently unclip the frame. There's 4 clips, 1 in each corner, and gently pull the underframe away. At the same time, just being a bit careful of any wires that are still connected. Just saves us soldering later. You can also see in this model that the stay alive capacitors are in the fuel tanks. The screw holding the body together isn't a proper threaded screw, it's like a hollow tubular self-tapper, so that's why I put a screwdriver between the 2 halves of the body, just slightly prise them apart as I'm moving the screw. My approach to these small models is, if you have to use a lot of force, then something's not right. It should always be just gently easing and separating things gently. Okay, so now we've got the body split, we can remove the motor and the worm gear and get the motor itself on the bench. And try not to throw it on the bench like me. Okay, so we continue stripping the motor down by pulling off the worm gear. We just give it a gentle pull from each end. And then we can get all these bits and put them in the parts box out the way, and then we can do some more testing on the motor. So this was actually over scale on the 200 milliamp range, so I've just swapped it over to 10 amps, so that's 0.32 amps or 320 milliamps. So that's not good. I'd expect 100 milliamps or less. And for comparison, this is a brand new Class 27 motor that I got from DCC Supplies, and you can see the running current is just over 50 milliamps, which is what you'd expect for a brand new motor off-load on the bench. So given that we're looking at best case with the motor cold on the bench and the loco was actually failing after 10 minutes, I think we'd declare the motor failed. So let me go and see, can I order a new Class 22 motor? Okay, so it turns out that I can't get a Class 22 motor anywhere. I can get Class 27 motors, no problem, but not a Class 22. So let's have a look if we can do anything with a Class 27 motor, because that's the best we've got, I think. So at first glance, the Class 27 motor is clearly not going to fit into the Class 22 frame. But if I can strip the Class 22 motor down, I can't imagine that the base motor frame from Dapol is going to be too different. They're not going to make loads of different motors, or the core motor anyway. So let's get these flywheels off and remove the plastic clips, and let's have a look how the base motor frame compares with the base motor frame on the Class 27 motor. Well, with the motors side by side, it looks really encouraging. The actual base metal frame of the motors look almost identical, so it seems quite possible that we could use the base metal frame from a Class 27 to build up a Class 22 motor. So let's have a look and see what we can do. Okay, so this is actually the old motor out of my Class 27. I think the actual motor's fine. The problem was these split couplings, and I glued them, and I used for the first and last time Gorilla Glue because I didn't realise how much it expanded, and it caused a problem inside the coupling. We ended up with the loco running noisily. So the actual motor I think is okay. Okay, so here's both motors stripped down to the bare frame. They are absolutely identical from what I can see. So I'm going to build the Class 22 plastic parts back up onto this 27 motor frame, and I think we're going to be onto a winner here, so let's have a go. Just before I build it back up, I'm just going to do a quick current check, so I've got a reference current later on when I put the motor back in the locomotive. Okay, well the plastic clip seems to fit okay, so far so good. I did try it the other way around, it does only fit it one way. So if you do this, just watch out for that. But other than that, it's fitting quite nice. These little terminal tabs, I can fold them back and cut them down as needed, but I can do that when the motor frame is back in the locomotive. Okay, so let's get the flywheels back on. Make sure they're nice and tight. Give them a good press. So that's one end done. And push it on the other end. Again, making sure it's nice and tight, and just check the motor rotates freely, no feeling of any binding of any sort. And that's why I took a current reference earlier, because I'll check the current later when it's back in the loco. Okay, so let's pop the flywheel couplings back on. So again, just pop it in, end one, and then the other end, click it in, end two. Okay, so that's the motor assembly. So now we can start putting that back into the loco frame and start to build it back up. Okay, so two halves together. Just need to make sure we put the insulating washer before we fasten it up. The insulating washer to insulate the two halves, of course. Screw it back up, and then we can put the captain tape on the top where the decoder will sit, the sound decoder, and then we can put the decoder in and get it wired back up. So just before we do wire the decoder up, now the mechanical bits are finished, we'll take a quick reference current again. You can see 88 milliamps, very similar to what it was. So that's indicative there's no binding mechanically of the motor now I've reassembled it. So that's all looking good. Okay, so that's the sound decoder back in, nicely insulated with captain tape. So now we can get the body on, and then we can get the two bogies back in and give it a test. So again, putting the body on, remember the marking, I've got it marked inside which way for the speaker. Gently slide it on, no force, just should be no resistance or very little resistance, just gently work it on, clip it into place, job's a good one. Okay, that's the body on. Now we can insert the bogies. I have recently cleaned the pickups and the terminals, or else, you know, this is a good opportunity to do that if you haven't. So as you put the bogies in, check they're free moving. Just if you feel any grinding or resistance, it's not quite right. So this one's got one of the terminals a bit proud there, so just gently bend it back down. The trick is just to get the spring tension just right, so you got a good contact with the pickup on the bogie, but so the bogie moves freely when you rotate it. Okay, and there we go. Okay, so that's the loco finished and put back together. So now let's get it on the track and give it a test. Okay, so we've got loco sound, we've got loco lights, so far so good. Let's give it a bit of throttle. And there you go, Dapol N-Gauge Class 22 fixed with a Dapol Class 27 motor. Don't forget, like and subscribe.